This is part 2 of section 3.1. We have been talking about graphing quadratic functions, and we've just worked or graphed an equation that was given to us in standard form. So we were able to read off our h, our k, and the a multiplier. Okay? So not everything is going to be given to us in that form. We could have something written out just as a general multiplied out quadratic. We have to have the x squared. Everything else here is optional. I could have a 1 here. As long as the x squared is there, I have a quadratic. Now, there is a way to transform this into standard form, and I will do this in an optional video at the end of this lecture. I'll show you exactly where all of this came from. But you must at least know that if we are given something in this form, you can find your vertex by doing this. Okay, now this can look a little bit scary, but it's really not that bad. We already know how to find b and a and everything else from using the quadratic formula. Okay, to find the vertex of a parabola, all you need to do is to find negative b over 2a. So whatever this value is, you're going to make it negative, divide it by this times 2, and you're going to have the x coordinate of your value right here. Okay. Now, this part, f of negative b over 2a, there is a formula for this, but really it's a lot easier just to figure out what your x value is, and then take your x value and plug it in and figure out what you get for your y value. Okay? And then the axis of symmetry is x equals what your x value is. So that part is the same. So if you know your vertex, you can get your axis of symmetry really easily. It's just x equals whatever x equals. And then the direction of the parabola is still by a. This a number in front of your x squared is the same a value that is right here. So that part works exactly the same. It's still going to tell us whether we're opening up or down. Okay? So let's look at this problem, and let's just say we want to find the vertex, axis of symmetry, and also how it opens. Okay? So let's say that our a value is the number in front of our x squared, which is negative 2. Our b value is 8, and our c value is negative 1. And we don't really need that for here. Okay? Now to find our vertex, we need to find negative b over 2a. So this is negative 8 over 2 times a, and a is negative 2. So I end up with negative 8 over negative 4, which is positive 2. So for my vertex, I know that it is 2 comma something, and my axis of symmetry is going to be x equals 2. I also know how it opens, even though you weren't specifically asked for this here. My a value is negative, so this opens down. Okay. Now to find the y value of our vertex, I want to take 2 and plug it in for x here. So I want to find f of 2. So this will be negative 2 times 2 squared plus 8 times 2 minus 1. So this is negative 2 times 4 plus 16 minus 1. Negative 8 plus 16 minus 1, and that's going to be positive 7. So the last part of our vertex is 2, 7. If you can remember negative b over 2a, you've got it. Don't let this part, the way it has to be written, scare you, because all you have to do is to take this value, plug it in, and do your arithmetic. As long as you remember your order of operations, you're going to be golden here. All right, so let's use this to do a full graph. All right, so I want to graph f of x is equal to 6 minus 4x plus x squared. Now, this is not the order we normally write things in. So normally, it would be x squared minus 4x plus 6. I'm going to be using the same steps. We want to know how does it open, what is the vertex, find x-intercepts, find y-intercepts, and then graph. Okay, so let's say, okay, our A is the number in front of our x squared, so that's a 1. Our B is -4. Our C is 6. The first step was, how does it open? Our A value is a positive number, so this thing should open up. Okay. What is our vertex? To find the vertex and the axis, I need to find -b over 2a first. So this will be -4 over 2 times a, which is 1. So I get 4 over 2, which is 2. So the x-coordinate of my axis is 2. The x-coordinate of my vertex is 2. The axis of symmetry is x equals 2. Now I just need to find the y value that goes along with it. So I need to find f of 2. So that is 2 squared minus 4 times 2 plus 6. 4 minus 8 plus 6 is 2. So the vertex is the point 2, 2, and the axis of symmetry is x equal to 2. Okay. Okay. Now I want to do a quick little sketch here. Okay. This is supposed to be my x-intercept step. My vertex is 2, 2. I'm not worried about specifics. It's right up there in that quadrant, 2, 2. My graph is supposed to open up. I didn't hit that vertex there. Okay, but if my graph opens up and this is my vertex, I should never cross the x-axis. So I do not expect to have any x-intercepts here. If I end up with x-intercepts, I need to double check. You can always do a quick sketch like this and get an idea of how many x-intercepts you should expect. On the problem we worked previously, the one we graphed previously, our vertex was down here and our graph opened up and we got 2 x-intercepts. Okay, now that aside. Now what I want to do is I want to try setting this equal to 0 and see what I get. So x squared minus 4x plus 6 is equal to 0. Now at first, it looks like it might be easy to factor, but if you try to think of two numbers that multiply to a 6 and add to a -4, you're not going to find any. It doesn't work. Okay, so let's go to the quadratic formula. We've already identified our a, b, and c here. So x equals -b, which would be +4, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a, which is 1. And if you do your arithmetic, you get 4 plus or minus the square root of, you're going to have a -8 over 2. Now right here, because that's a negative number, I have 2 complex solutions. Meaning that there's going to be an I in my answer. That means there are no x-intercepts. If this had been anything other than a negative, I would have been able to find at minimum 1 x-intercept to graph. But this gives me imaginary answers, so I can't plot that. It doesn't ever cross. Okay, and then step 4 is to find our y-intercept, which we will always have. So plug in f of 0. And if I plug in 0, I get 0 squared minus 4 times 0 plus 6. So this is just 6. All right, so now let's put all of this stuff on our graph. Okay, so I know that it opens up. All of my information should force this to happen. Okay, my vertex is the point 2, 2, which is right here. My axis of symmetry goes through 2. So I'm going to put a dotted line through here. And I know I have symmetry about that line, so I can make that happen if I need to, and I will. I would plot my x-intercepts if I had any, but I don't have any. My y-intercept is 6. 1, 2, 3, 4, 5, 6 is right here. Okay, so right now I have 2 points. I can use symmetry to get a third. I'm 2 units away from my axis of symmetry right here, so I'm 2 units away on this side as well. And if I wanted to plot some more points, I could. I could plug in x equal 1, see what I get, x equal 3, so on. But if you know your basic shape of your graph, and remember, I know that you're eventually going to be using graphing calculators, so it's I know that you are going to be using your ability to look at this mainly as a way of checking that your graph makes some sense. So let's connect these with a smooth line. You have your graph, and that is your answer.